Hi everyone, this is Miss Afric here, and today we're going to be talking about general angles and something you haven't heard of yet called radian measure. Alright, now so far you've only known one way to measure an angle, and that's in degrees. But today we're going to talk about a second way to measure an angle, and it's actually a way that most of the rest of the world uses instead of degrees, and that's called radians. Okay, now I know you haven't heard of a radian, so I'm going to show you a quick little visual graphic of what a radian is to see if it kind of makes a little more sense. Okay, a radian is the angle made by taking the radius of a circle and then wrapping it along the edge. So let's take a look at this visual. Alright, we take the radius, wrap it along the edge, and that angle created is called a radian. Okay, so that right there is a radian, and it should make a little more sense now. We're going to be dealing a lot with radians in the next few sections, so you're going to want to start getting used to them. Alright, so we'll work with them a lot today and then in the upcoming days as well. Now, when it comes to knowing angles, we do have to know certain special angles in both degrees and radians just off the top of our head. So let's go through those angles first. If we start here at 0, we'll call this arbitrary 0. Okay, let's start with degrees. If I want to start here at 0, does anybody know how many angles are in a full circle? That's right, 360. So there are 360 degrees in a full circle. That would mean in half of a circle, there should be 180 degrees. Alright, and then these coordinate lines actually kind of cut it into fourths, right? 1, 2, 3, 4. So if I cut 360 degrees into fourths, I'm at 90 degrees. And that one should make sense because it's a right angle. Now this bottom one's usually the hardest one to figure out, but we're just going up by 90 degrees, so 0 plus 90 is 90, plus 90 is 180, plus 90 brings us to 270, and add another 90, we're back at 360. Alright, so those are the important angles to know in degrees. Now let's talk about them in radians. Okay, in radians, this is still arbitrary 0, but we have to know how many radians are in each degree. Well, let's take a look at this visual again, because it kind of demonstrates it pretty nicely. Alright, we've got 1 radian, 2 radians, 3 radians, plus a little extra in 180 degrees. That turns out to be pi. So there are pi radians in 180 degrees. That would mean if in half a circle there's pi radians, in a full circle there's 2 pi radians. Okay, and then once again we're cutting that 2 pi into fourths. So if I cut 2 pi into fourths, it's the same thing as pi over 2. So this angle right here is actually pi over 2 radians. And once again we can do it the same way we did in degrees. Add pi over 2. If I add another pi over 2, remember pi over 2 plus pi over 2 gives us 2 pi over 2, which is just pi, right? So we end up at pi. And if I did that math again, I would end up with 3 pi over 2. Or in other words, 3 halves pi. So 1.5 pi, right? That should make sense. It's half a pi, 1 pi, 1.5 pi, 2 pi. These angles are really important. We call these 4 angles, technically 5 if you count 0, the quadrantal angles, because they are the angles that split this circle up into quadrants. And in case you've forgotten what the quadrants are, we got quadrant 1, quadrant 2, quadrant 3, and last but not least, quadrant 4. Okay, so these 8, technically 9 if you count 0, angles are ones that you're going to want to know off the top of your head. So from now on, if I ask you what this angle is right here, I want you to just know it's 270 or 3 pi over 2. Alright, then let's move on. Next thing we're going to talk about is how to convert from degrees into radians and from radians into degrees. Okay, in order to rewrite a degree measure into radians, we're going to multiply by pi divided by 180 degrees. That comes from the fact that we know this conversion factor, right? There are pi radians in 180 degrees. So it's a conversion factor kind of like how there are 12 inches in a foot or 60 minutes in an hour, right? It's just a conversion factor. So if it helps, you can think of it that way. And then to rewrite radians into degrees, we're just going to flip-flop it multiply by 180 degrees over pi. So let's see how this works. Example 1. We're converting between degrees and radians. So in letter A it says convert 110 degrees into radians. So if I want to convert degrees into radians, degrees to radians, I'm going to use this conversion factor right there. So I've got 110 degrees times pi divided by 180 degrees. I'm going to turn this into a fraction to make it easier and just multiply straight across. Okay. What you should notice here is these degrees cancel out because it's degrees divided by degrees. That's how you know you chose the right fraction to multiply by. Those degrees should cancel out. So now I'm left with 110 pi divided by 180. And then you got to simplify those numbers. Now be careful, if you're going to use your calculator, don't type pi in there because otherwise you're going to get a decimal. Just type the numbers and simplify them on their own. And then put pi back in when you're done. So we're left with 11 pi divided by 18. And that should always be exact, just so you remember. Alright, to convert negative pi over 9 radians into degrees, well, radians into degrees, multiply by the other way. So negative pi divided by 9 times 180 degrees divided by pi. Let's see if you can finish that one on your own. I'm leaving you with the easy part right there because I know you guys can handle that. Alright, finish that one on your own. Bring your answer to class tomorrow or whenever you have class next. Okay, then let's keep moving on. Let's talk about angles in standard position. When we refer to an angle in standard position, what we mean by that is the angle, the initial side of the angle, should be on the positive x-axis. Positive x-axis. So if we look at this coordinate plane, here's my x-axis. This is the positive side. So my initial side should be right there on the positive x-axis. Then we'll also have a terminal side wherever the angle is. Alright, so this side right here, for example, would be my terminal side. And in case you didn't know, terminal, that would mean like ending, right? So it's where our angle ends. That makes sense. Alright, now the really important part of these angles is that we can have positive angles and we can have negative angles. So you really have to know which one you're dealing with and you have to label it in your picture. Okay, positive angles always start at our initial side and go up, whereas negative angles start at our initial side and go down. So if I was trying to draw a positive angle here, I would go up and draw the arrow that way. If I was trying to draw the negative side, I would go down and draw the arrow this way. So it's really important that you label your angles when you sketch them with this arrow right here. Alright, well let's try sketching some angles, how about? In example 2, we're going to draw an angle with the given measure in standard position, then tell in which quadrant the terminal side lies. Alright, well in letter A, I've got 210 degrees, so I know that I want it to be in standard position. Standard position means my initial side is to be on the positive x-axis, so I can at least get that drawn. Then I'm looking to draw the angle that ends at 210 degrees. Well, those quadrantal angles that we talked about earlier are going to come in handy here. So I know this is 0 because it's where I'm starting. This is a positive angle, so I'm going to be moving in the positive direction. So this would be 90 degrees. This would be 180 degrees, 270 degrees, and 360 degrees. Right? And remember, I could keep going. 360 plus 90 would give me 450 degrees. Right? I can keep going from there. But hopefully you recognize that 210 degrees lies between 180 and 270. So right here. Alright, so then the final little step that I have to do to finish this is to draw that little extra arrow. Now this is a positive angle, and I'm just going straight to this side. So there's my 210 degrees. Okay, and then the last little piece again, tell in which quadrant. Well, remember, quadrant 1, 2, 3, 4. So this would be in quadrant 3, Q3. Alright, if you feel like you need to see that again, make sure you rewind before moving on to the next one. Otherwise, we shall try letter B. Once again, I'm going to start by drawing. That was a bad one. Let's try that again. One more time. There. Alright, by drawing, we're sketching negative 120 degrees now. Don't worry, it's negative, but we know how to handle that, okay? We still have the same initial side on the positive x-axis. But now, since I'm moving in a negative direction, I'm going to want to actually draw negative angles, okay? Now, something that might help you visualize this, I'm going to flip over for 1 minute, okay? This is just a little graph that shows initial side, terminal side. And if I move this around, you can see that angle is changing, right? Well, we know this angle right here is 90 degrees. If we think of it as a negative angle, that angle will actually become negative 270 degrees. Alright, so every angle that we have in positive form, for example, 270 degrees, alright, we can also think of it in negative form as negative 90 degrees. So in these problems, when you're dealing with a negative angle, well, labeling it like the way we did in letter A isn't going to help you. We want to label it with negative angles. So I'm still going to start at 0, but now I'm going to go negative 90, negative 180, negative 270, and negative 360. And again, I could keep going if I needed to, but hopefully we see that negative 120 lies right about here. And since this is a negative angle, I'm starting at 0 and going down. So I want to draw that little arrow. And this angle also happens to lie in quadrant 3, Q3. Excellent. Okay, letter C. Ooh, letter C is a little tricky, but I think you guys are up for the challenge. So I want you to try this one on your own. Try on your own. Okay. And we will make sure that we go over it in class when we see you next. Okay. And then letter D, I'm actually just going to save for class because I want to make sure we are able to talk about the radians and how we would sketch that as well. All right, so save that for class. You can try it if you want, but I think we're going to save that one for class. All right, the last thing I want to talk about is what coterminal means. Okay, what I want you to really notice from that word is the word terminal. Coterminal means two angles. Two angles are coterminal if they have the same terminal side. Remember, the terminal side, that's where it ends. Okay, so if you can picture it, right, if I have a, let's see, initial side, terminal side right here, if I wanted to get an angle with that same terminal side, well, I would just have to start with this one and then add that full circle and I'd be back where I started. So to get coterminal angles, we are going to be adding or subtracting the full circle, which in degrees would be 360 degrees, or in radians it would be 2 pi. Right, so that's how we can find coterminal angles. So in example 3, it says find one positive and one negative angle that are coterminal with the following angles. So if I have, for letter A, negative 60 degrees. Well, to find a positive angle, I'm going to go ahead and add 360 degrees, the full circle, to negative 60. Negative 60 plus 360 is 300 degrees. So there's my positive coterminal angle. And if you were to sketch both of those, you would see that they have the same terminal side. Okay, to get my negative one, I'm going to do negative 60 degrees minus 360, which is negative 420 degrees. So one positive, one negative, I'm good. Alright, let's try letter B, because that one is in radians. So, radians, same idea, but now we're going to be using our radian measure. So, 7 pi over 4 plus 2 pi. Well, if I want to add fractions, I need common denominators. So to get my denominator before, I'm going to multiply by 4 over 4. That would be 7 pi over 4 plus 8 pi over 4, which is 15 pi over 4. So there's my positive coterminal angle. Then I would do the same idea, but subtract 2 pi to get my negative one. Okay? And once again, I'd have to get a common denominator, and I should end up getting negative pi over 4. Okay? Alright, try C and D on your own. If you're still confused, please make sure you rewatch it.